Picture this. It's 1962. A guy pulls up to a stoplight in his work truck, paint splattered, tools rattling in the bed, maybe some lumber sticking out the back. Next to him, a pristine Jaguar E-Type purrs expensively. The light turns green. The Jag driver floors it, expecting to leave this blue-collar hauler in the dust. Instead, he watches in disbelief as the Chevy truck walks away from him like he's standing still. Welcome to the world of the 327 small block V8, the engine that turned American pickup trucks into accidental supercars. This is the story of how Chevrolet created an engine so good, so versatile, so ridiculously overbuilt that it didn't just power trucks. It embarrassed European sports cars, costing 5 times as much. An engine that started life hauling hay and ended up winning races. An engine so successful that its DNA lives on in every modern GM V8 to this day. To understand why the 327 was revolutionary, we need to travel back to the late 1950s. The American automotive landscape was changing rapidly. The horsepower wars were heating up, but there was a problem. Most powerful V8s of the era were massive, heavy boat anchors. Ford's 390 FE weighed 650 pounds. Chrysler's 392 Hemi tipped the scales at nearly 700. These engines were powerful, sure, but they were also fuel-hungry, expensive to produce, and about as refined as a sledgehammer. Meanwhile, across the Atlantic, European manufacturers were building high-revving, sophisticated engines. Ferrari's Colombo V12 made 280 horsepower from just 3 liters. Jaguar's XK inline-6 produced smooth, refined power. But these engines cost a fortune to build and required constant maintenance. A Ferrari engine rebuild cost more than most Americans made in a year. Enter Ed Cole, Chevrolet's chief engineer, and a man who understood something fundamental. Americans wanted European performance at American prices. They wanted reliability without sacrifice. They wanted an engine that could haul a trailer on Monday and win a drag race on Sunday. Cole's team had already shocked the world in 1955 with the original small block V8, a 265 cubic inch marvel that weighed just 530 pounds. But by 1962, they were ready to perfect the formula. The 327 cubic inch small block didn't happen by accident. It was the result of systematic evolution. Chevrolet's engineers started with the 283, itself a bored-out version of the original 265. They increased the bore to 4 inches and stretched the stroke to 3.25 inches. Simple math, but the execution was anything but simple. The cylinder walls were kept thin using advanced casting techniques, saving weight while maintaining strength. The crankshaft was forged from premium steel, carefully balanced to handle sustained high RPM operation. The connecting rods were shot-peened for strength, a process that bombarded them with tiny steel pellets to create a compression layer that resisted fatigue. But here's where it gets interesting. Chevrolet didn't build just one 327. They built a whole family of them, each tuned for different purposes. The base L30 made 250 horsepower with a 2-barrel carburetor. Respectable, efficient, perfect for trucks. The L74 stepped up to 300 horses with a 4-barrel carb and higher compression. The L75 pushed 340 horsepower. But the crown jewel, the engine that would become legendary, was the L84. The L84 was insane. Fuel injection in 1962 wasn't electronic, it was mechanical, using a Rochester ramjet system that was basically a glorified diesel injection pump modified for gasoline. This system used a high-pressure pump driven off the distributor shaft, sending fuel through individual lines to each cylinder's intake port. No carburetor, no throttle plates in the traditional sense, just pure, metered fuel delivered exactly when and where it was needed. The specifications were pornographic for the era. Compression ratio, 11.25.1. That's higher than most modern performance engines running on pump gas. The engine demanded 102-octane fuel minimum. Chevrolet recommended Sunoco 260, the highest octane commercially available. Solid lifter camshaft with 346 degrees of duration and 0.485 inches of lift. Those numbers meant this engine had a choppy idle that sounded like barely controlled violence. Forged aluminum pistons from Mickey Thompson's shop. Forged steel crankshaft. Heavy-duty valve springs that could handle 6,500 RPM all day long. The result? 360 horsepower at 6,000 RPM, 352 lb-ft of torque at 4,000 RPM, from 327 cubic inches. Let me put that in perspective. Ferrari's 250 GTO, the most exotic sports car of 1962, made 300 horsepower from its V12. The Jaguar E-Type's 3.8-liter inline-six produced 265 horsepower. The Mercedes-Benz 300 SL, with its sophisticated fuel injection, managed 215 horsepower. The Chevy 327 destroyed them all. But raw numbers only tell part of the story. The 327's real genius was its versatility. This same basic engine architecture could be found in everything from grocery-getter Impalas to Corvette race cars. A farmer could order a C10 pickup with a 327 and tow his boat to the lake, then smoke a Porsche 3M56 at the stoplight on the way home. The engine was so understressed in its lower output versions that it would run for 200,000 miles with basic maintenance. Oil changes, spark plugs, maybe a timing chain at 100,000 miles. That was it. The truck versions were particularly interesting. Chevrolet offered the 327 in their C10 and C20 pickups starting in 1966, though enterprising dealers had been swapping them in since 1962. The most common truck variant was the L30, producing 250 horsepower. Doesn't sound like much today, but consider this. The average 1960s pickup truck made about 135 horsepower. The 327-equipped trucks nearly doubled that. More importantly, they made usable torque from idle to redline. You could lug the engine down to 500 RPM in high gear, floor it, and it would pull cleanly without complaint. The 327's compact dimensions were crucial. At just 28 inches wide and 27 inches tall, it fit in engine bays designed for inline-six engines. Weight distribution improved dramatically compared to big block-equipped trucks. A 327-powered C10 had nearly 50-50 weight distribution, empty, unheard of for a pickup. This meant it actually handled. Contemporary road tests describe these trucks as sports cars with beds. Testing data from 1967 shows just how quick these trucks were. A C10 with the L30 327 and 3-speed manual could hit 60 mph in 8.9 seconds. The quarter mile came up in 16.8 seconds at 82 mph. With the optional 4-speed and 3.73 rear gears, those numbers dropped to 7.8 seconds and 15.9 seconds respectively. For context, a 1967 Jaguar XKE 4.2 did 0-60 in 7.0 seconds. A Porsche 911S managed 8.0 seconds. The truck was right there with legitimate sports cars. But wait, there's more. Because the 327 shared its architecture with every other small block Chevy, the aftermarket exploded. Edelbrock made intake manifolds, Hooker-built headers, crane-ground camshafts, TRW forged pistons. For a few $100s, you could turn your work truck into a street terror. Magazine builds of the era show 327 powered trucks running 13-second quarter miles with basic bolt-ons. That's faster than a modern V6 Camaro. The secret sauce was the cylinder head design. Chevrolet's engineers had perfected what they called wedge chamber combustion chambers. Unlike the complex hemispherical designs used by Chrysler and others, the wedge was simple, cheap to produce, and incredibly effective. The intake valves were canted at 23 degrees, the exhausts at 17 degrees. This created excellent mixture motion. The fuel and air swirled as they entered, promoting complete combustion. The spark plug was positioned perfectly to initiate flame propagation across the chamber. Port design was equally clever. The intake ports were deliberately kept small, just 1.94 inches for the intake valves, 1.5 inches for the exhausts on standard heads. This seems counterintuitive, but small ports mean high velocity. High velocity means better cylinder filling at low and medium RPM, where trucks spend most of their time. The famous Fuelie heads used on the L84 had the same valve sizes but polished, matched ports that flowed 15% more air at high lift. The valve train was bulletproof, stamped steel rocker arms with a 1.5.1 ratio, simple, effective, impossible to break. The push rods were hollow, serving as oil passages to lubricate the rocker arms. The camshaft rode in 5 Babbitt bearings that would last essentially forever with clean oil. Hydraulic lifters on most versions meant zero maintenance, no valve adjustments ever needed. The bottom end was equally robust. The 2-bolt main bearing caps were sufficient for street use, though Chevrolet did produce 4-bolt main blocks for racing. The crankshaft was cast iron on base engines, forged steel on high-performance versions. All versions got floating piston pins and cast aluminum. Pistons, though the high-compression variants used forged units. The connecting rods were forged steel with fractured caps, a manufacturing technique that created perfect alignment between rod and cap. Cooling was handled by a simple but effective system. The water pump pushed coolant through the block first, then up through the heads, and finally out through the thermostat housing. This reverse flow cooling kept cylinder temperatures even, preventing hot spots that could cause detonation. The radiator was positioned directly in the airstream, and trucks got extra cooling capacity, typically 23-inch wide radiators compared to 17-inch units in cars. The Rochester ramjet fuel injection system deserves special attention. This wasn't some primitive throttle body setup. Each cylinder got its own injector nozzle. A high-pressure pump maintained 200 psi in the fuel rails. The metering was controlled by a bell crank connected to the accelerator pedal, which moved a shuttle valve that varied fuel flow. A separate enrichment circuit handled cold starts and acceleration. The system was so precise that fuel economy actually improved compared to carbureted versions, despite the massive power increase. Of course, fuel injection had problems. The nozzles could clog if you used dirty gas. The high-pressure pump was noisy. The whole system cost $538 extra in 1962. That's $5,200 in today's money. Most buyers opted for the dual-quad L76 instead, which made 340 horsepower and cost half as much. But for those who wanted the ultimate, the L84 was untouchable. The 327's influence on motorsports was immediate and lasting. In SCCA production racing, 327-powered Corvettes dominated the engine-powered Chaparral race cars to Can-Am victories. In Trans Am, when the rules required engines under 305 cubic inches, teams simply destroked the 327 to 302 cubic inches, creating the legendary ZIT-28 engine. This destroked 327, with its short stroke and huge bore, could rev to 7,000 RPM and made 360 horsepower in race tune. Drag racers loved the 327 because it was light and strong. A fully dressed 327 weighed about 540 pounds, 200 pounds less than a big block. That weight came off the front axle, improving weight transfer during launches. The short stroke meant less stress on the reciprocating assembly at high RPM. Builders discovered the factory blocks were good for 550 horsepower, naturally aspirated, 700 with nitrous oxide. The street racing scene of the 1960s was dominated by 327-powered cars and trucks. The engine's broad power band made it perfect for stoplight-to-stoplight battles. Unlike high-strung imports that needed perfect shifts and high RPM to perform, the 327 would pull from any gear at any speed. Miss a shift? No problem. The torque would cover your mistake. But here's the thing about the 327. It wasn't just about performance. This engine changed American automotive culture. Before the 327, if you wanted a fast vehicle, you bought a sports car. After the 327, everything could be fast. Your dad's pickup could embarrass a Mercedes. Your mom's wagon could outrun a Triumph. The democratization of speed had begun. The economic impact was equally significant. A base C10 pickup with the 327 cost about $2,400 in 1967. A Jaguar XKE cost $5,500. A Ferrari 275 GTB cost $14,000. Yet the Chevy could match or beat their straight-line performance while hauling a half-ton of cargo. For working-class Americans, the 327 represented something previously impossible: supercar performance at blue-collar prices. Insurance companies didn't know what to do with these trucks. They were classified as commercial vehicles, so insurance was cheap. A 20-year-old could insure a 327-powered C10 for less than a V6 Camaro would cost today, adjusted for inflation. This created a whole generation of young enthusiasts who cut their teeth on small block power. The 327's production run was relatively short but incredibly influential. From 1962 to 1969, Chevrolet built millions of these engines. They powered everything from Chevelle to Corvettes, Novas to pickups. When emissions regulations killed the high-compression versions in 1970, the 327 was replaced by the 350, essentially the same engine with a longer stroke. But the 327's DNA lived on. The 350 was a 327 with a different crank. The later 383 stroker was a 350 block with a 400 crank, but the architecture was pure 327. Today's LS engines, with their aluminum blocks and computerized fuel injection, can trace their lineage directly back to Ed Cole's small block design. The bore spacing is identical. The valve arrangement is the same. The pushrod actuation remains. It's evolution, not revolution. Surviving 327s have become highly collectible. A date-coded L84 fuel injection unit can sell for $30,000. Even a basic two-barrel 327 from a truck commands $3,000 to $5,000 rebuilt. The fuely Corvettes that everyone dismissed as too complicated in the 1960s now trade for six figures. Restored 327-powered pickups routinely sell for more than they cost new, adjusted for inflation. The modern performance world owes everything to the 327. It proved that American manufacturers could build sophisticated high-revving engines. It showed that fuel injection could work in production vehicles. It demonstrated that one basic engine design could power everything from economy cars to race cars. Most importantly, it proved that performance didn't have to be expensive or exotic. Consider the contemporary alternatives. If you wanted 360 horsepower in 1962, you could buy a Ferrari 250 GT. It would cost you $13,000, require constant maintenance, and strand you regularly. Or you could buy a Corvette with the L84 327 for $5,200, run it hard for 100,000 miles, and rebuild it in your garage with hand tools. The Ferrari might have been more exclusive, but the Chevy was the better engine by every objective measure. The 327 also changed how Americans thought about trucks. Before this engine, trucks were utilitarian appliances. After the 327, they became performance vehicles that happened to have beds. This transformation created the modern performance truck market. Every Raptor, every TRX, every Sierra AT4 owes its existence to those first 327-powered C10s that proved trucks could be fast. Racing technology trickled down faster with the 327 than any previous engine. The solid lifter cam from the L76, you could order it from the Chevrolet parts counter. The fuel injection from the L84, available as a dealer-installed option. The 4-bolt main block from the race engines. Any speed shop could get one. This accessibility transformed hot rodding from a fringe hobby to mainstream culture. The technical innovations pioneered in the 327 became industry standard. Thin-wall casting techniques, induction-hardened valve seats, precision weight-matched rotating assemblies, high-flow wedge combustion chambers. Every V8 built today uses technologies refined in the 327 program. So what made the 327 so special compared to its competitors? It wasn't any one thing. It was the combination of factors: Lightweight, but strong construction. High revving capability, but low-end torque. Sophisticated engineering, but simple maintenance. Racing performance, but pickup truck reliability. The 327 was the Swiss Army knife of engines. Good at everything, perfect for America. The engine's versatility extended to fuel choices. While the high-compression versions demanded premium gas, the truck engines ran happily on regular. This flexibility meant you could build a 327 to match your budget. Want maximum power? Run aviation gas and solid lifters. Need economy? Lower compression and regular fuel. The same basic engine could be configured for any application. Let me give you some perspective on just how ahead of its time the 327 was. The specific output, horsepower per cubic inch, of the L84 was 1.1. That means it made more than 1 horsepower for every cubic inch of displacement. In 1962, only exotic racing engines achieved this. Most production engines made about 0.7 horsepower per cubic inch. The 327 was literally racing technology you could buy at a Chevrolet dealer. The aftermarket support for the 327 created an entire industry. Speed shops that had survived on flathead Ford parts suddenly had thousands of new customers. Companies like Edelbrock, Holley, and Crane expanded rapidly to meet demand. The SEMA trade organization, now a massive industry force, grew from 35 members to over 500 during the 327's production run. Cultural impact went beyond just car culture. The 327 appeared in songs, movies, and television shows. Bruce Springsteen sang about a 396 and fuelie heads, technically impossible since fuel injection was never offered on the 396, but the imagery stuck. The Beach Boys' 409 was about the big block, but more kids actually owned 327s. Every teen movie of the era featured someone with a hopped-up 327. The international racing success of the 327 changed how the world viewed American engines. When Jim Hall's 327-powered Chaparrals dominated Can-Am racing, European teams took notice. When Roger Penske's 327-powered Camaros won the Trans Am Championship, it proved American engines could do more than just go straight. The 327 earned respect through results. Quality control on the 327 was exceptional for the era. Chevrolet used statistical process control, unusual for the 1960s. Every 20th engine was pulled from the line and dyno tested. If it didn't meet specifications, the entire batch was checked. This attention to detail meant that performance was consistent, a crucial factor for racers who needed predictability. The 327's successor, the 350, became even more successful, but it never quite captured the magic of the original. The 327's short stroke and large bore gave it a rev-happy character the 350 couldn't match. Professional engine builders still prefer 327 blocks for high RPM applications. The harmonics are better, they say. The engine is happier at speed. Today, building a 327 is a statement. You could easily build a 383 or 406 for the same money and make more power. But enthusiasts choose the 327 for its character, its history, its sound. There's something special about an engine that revs to 6,500 RPM and sounds like it wants more. Something satisfying about rowing through the gears and feeling that instant throttle response. The environmental story is interesting too. While the 327 predated emissions controls, it was remarkably clean for its era. The efficient combustion chamber design meant less unburned hydrocarbons. The precise fuel injection on L84 models produced fewer emissions than contemporary carburetors. When catalytic converters arrived in 1975, the basic small block design adapted easily. Looking back now, the 327 represents a perfect moment in automotive history. Computing power hadn't yet taken over engine management. Engineers still relied on intuition and experimentation. Every improvement came from someone's flash of insight, tested on a dyno, proven on a track. It was analog engineering at its finest. The legacy question is simple. Could the 327 phenomenon happen again? Probably not. Modern engines are so complex, so integrated with electronics, that the kind of grassroots modification culture the 327 created is impossible. You can't port modern heads in your garage. You can't grind a custom cam and make it work without reprogramming the ECU. The 327 existed in a sweet spot where technology was advanced enough to make serious power, but simple enough for individuals to understand and modify. But perhaps that's what makes the 327 so special. It represents the last moment when a regular person could fully understand their engine, when you could diagnose problems with your ears and fix them with your hands, when performance was about mechanical sympathy, not software updates. The philosophical truth about the 327 is that it democratized performance. Before this engine, speed was for the wealthy. After it, anyone with a wrench and determination could go fast. That transformation changed America. It created car culture as we know it. It inspired generations of engineers. It proved that excellence doesn't require exclusivity. Today, when you see a restored 327-powered truck at a car show, you're not just looking at an old engine. You're looking at a revolution, an engine that took Ferrari performance and put it in farm trucks, an engine that proved American engineering could match anyone in the world, an engine that turned everyday vehicles into giant killers. The next time you see a modern performance truck, maybe a supercharged F-150 or a twin-turbo Silverado, remember that it all started with the 327. Some guy in 1967 figured out that his work truck didn't have to be slow. That revelation changed everything. The 327 didn't just power trucks. It powered dreams. And in the end, that might be its greatest achievement. What's the most unexpected vehicle you've seen with serious power? Drop a comment below and let me know. If you enjoyed this deep dive into one of history's greatest engines, hit that subscribe button for more stories about the machines that changed our world. Until next time, keep those engines running.